Okay, welcome to Accelerated Math. Determine the graph of a one variable absolute value inequality. Whew, big title. Let's see what it's all about. Alright, this first one, I tried to start with a little bit of a simple one here. And inequality, so when it talks about inequality, it's talking about this symbol right here, greater than, less than. So here's the less than symbol. Less than. Looks a little bit like an L, almost. Not quite, but anyway, it looks like an L that got bent over a little bit. Alright, the other one is the greater than symbol, and you do need to kind of be able to recognize those as opposed to just saying the alligator eats the big one, which is fine for learning initially, but we need to know that this what those symbols mean. Alright, so when I put an X in front of here and a 10 there, I'm saying X is less than 10. When I put an X here and put a 10 there, I'm saying X is greater than 10. If I use this symbol, I put an X on this side and a 10 there, that's the greater than symbol. But we typically read it from the X side, so we would say X is less than 10. So this is kind of a backwards way to write it. Alright, just a little intro. Absolute value. What do they talk about absolute value? Well, these are my absolute value bars. And if you've had any exposure to absolute value, which I suspect you have, is you know that absolute value is the distance something is away from zero. So if they ask about the absolute value of 5, they're saying, how far is it from 0? It's 5 units. The absolute value of -5 is the same value. It's how far is it from 0? It's still 5 units away. So a lot of people kind of summarize that and say absolute value means the positive of it. Well, it means how far it is from 0. Alright, let's see if that helps us out in this stuff. Alright, so we got absolute value. The absolute value of 4x has to be greater than or equal to 12. And there's going to be a range of values that are going to fit this. If I put a 2 in here, for example, for x, 2 times 4 is 8. The absolute value of 8 is not greater than 12, so 2 is not an answer. If I put a 10 in here, 10 is an answer. 10 times 4 is 40. The absolute value of 40 is greater than 12. All right, so if I put a -10 in there, -10 times 4 is -40, but the absolute value of -40 is 40, which is greater than 12. So there's going to be a range of values that work for it. Here's how we figure it out. What we do is once you have just absolute value on this side, which this one already does, we call that isolating the absolute value portion of this, then you can split it into two problems. Now this is a greater than, and I'm mispronouncing that just a little bit on purpose, greater. Now I'm even misspelling it because this one is going to say that, you know what, 4x is greater than or equal to 12, or 4x is greater than or equal to -12. I'm sorry, I said that wrong. We're going to flip the symbol this time, less than or equal to, and change the sign. So we flipped that symbol and we made this one negative. Sorry, it's early in the morning here. I'm not thinking right. Alright, so when it was greater than, we're going to do an or statement, and you're going to find out when it's a less than symbol, we're going to do an and statement where it's in between some things. Alright, we're going to solve these two separately. Divide by 4 on both sides, and x is greater than or equal to 3. Alright, you remember a minute ago 10 was a valid answer. Well, it is greater than 3. Alright, I'm going to divide on this side by 4. The cool thing is you do the same thing to both sides, both equations. X is less than or equal to -3. How can x be greater than 3 and less than -3? Well, it can't. That's why we use the or statement. And I want to see which one of these matches up with that. Well, it's A, because here's 3, here's -3. This shading over here on this side is saying greater than 3. The shading on this side is saying less than 3. And these solid dots right here are saying or equal to. Alright, and you see the options. They were trying to maybe get you to pick this one. This one would have been if it was a less than statement, less and then we would have mispronounced it and used the word and in there. So it would have to be between those two. It would be less than 3 and greater than -3, which puts it in between. But it wasn't that one. Alright, it was A. Alright, let's go see some slightly more complicated ones and see what we can get here. Alright, so this one, what's different about this absolute value inequality is that it has a little something on the outside over here, and we need to get rid of that first because I said that we need to isolate the absolute value portion. Well, this is -3, we're going to do +3. plus 3 to both sides. Now we have isolated the absolute value portion. Alright, and now it looks very similar to the previous one. Now this is a less than statement. Less than. I'm mispronouncing and misspelling again. Less than. So we're going to use the and kind of function here. So we're going to say that, you know what, 2x minus 2, we're dropping the absolute value bars, must be less than 10, and it must be the same thing, greater than or equal to negative 10. Alright, some people may have done this a little differently, but this is just one way to do it. Then we're going to plus 2. I like this, lining it up like this, because you can do the same thing to both equations at the same time. We got 2x less than or equal to 12, and 2x is greater than or equal to negative 8. Watch your positives and negatives while you're doing this. We're going to divide by 2. X has to be less than or equal to 6, and a double condition. Oh boy, my handwriting's getting bad here. We're going to divide by 2, and x has to be greater than or equal to negative 4. So it's kind of a dual statement, and it's really kind of in between those two. What it's saying is, on the number line, that if you look at, well, negative 4 over here and positive 6 over here, that it has to be, it had to be greater than or equal to this one, going this way. Had to be less than or equal to 6, going this way. And that's where the two meet, so that's what we're looking for. Negative 4 to positive 6 looks like it's B. They may have tried to get you to choose, you know, something like this one over here where it was going on the outsides. Alright, but we knew better. Alright, I may show you a slightly different way if I get another one like that. Alright, here we got more stuff on the outside. This time a good bit of stuff on the outside, so I chose this one so that you get to see this. This is a greater than, greater, so we're going to have an or statement. So the and statement, it was shaded inside. The or statements are shaded on the outside of the two dividing points. Alright, so but before we can do this little splitting up thing, we've got to isolate the absolute value portion. So I'm going to do plus 2 to both sides. I've got 2 times the absolute value of x is greater than or equal to 12. Then I've got to get rid of this 2 on the front end. Some people might say minus 2, but it's not saying 2 plus the absolute value of x. It's saying 2 times the absolute value of x, and I've got to do the opposite of that. So I'm going to divide it by 2, divide this side by 2. That cancels that. I got the absolute value of x is greater than or equal to 6. Now I have this isolated. Now I can split it. I say x is greater than 6, greater, or x is, now I'm going to flip the symbol and change the sign, negative 6. And we didn't even have to do any math after this. That's it. Alright, so where do I have greater than or equal to 6 and less than or equal to 6? That's this one. Alright, here I just showed this. This is already isolated, so I would just split it. It was a greater than statement. 2x plus 5 greater than 11, or greater 2x plus 5 less than, flip the inequality and change the sign of the result. Alright, we can do both at the same time. Minus 5, minus 5. We're doing that from both equations, both sides of those equations. And over here, 2x less than or negative 16. Watch all those signs. X is greater than 3, or x is less than negative 8. So those are the two I'm looking for. It's got to be greater than 3 over here, or less than negative 8. It is C. Notice these things are open this time. Sorry, that very good. That open circle, that's because it didn't have an or equal to kind of statement there. So watch for that. And all of those were open circles. Okay, I think this is the last one. I chose this one because it's a little bit different from one respect. Alright, so it's already isolated, so we're going to split it. It's a greater than, so we're going to do this. Greater than 3, or greater 3 minus x is less than. I'm going to flip that inequality symbol and change the the answer over there to negative. Alright, let's see, is this plus 3 or minus 3? I know it says 3 minus x, but it's a positive 3 over here, so to get rid of it I got to do minus 3 to both sides. I can do all of these at the same time. I got negative x greater than, well, that comes out to 0. Over here I've got negative x less than negative 6. Okay, this negative in front, that bothers me because we need to get it down to just x. Well, it's not just negative x, it's really like a negative 1x. So to get rid of that negative, I'm going to divide by negative. What happens when you divide negative by negative? It changes it to positive. By the way, do you remember from about 8th grade when you learned about inequalities, inequalities like this, where you're solving, that when you divide by a negative you have to flip the symbol, the inequality symbol? Dividing or multiplying by a negative cause that symbol to flip. So this really changed our answers a good bit. So x has to be less than 0, x has to be less than 0 or greater than 6. Looks like it's less than 0 or greater than 6 over here. Boy, if you didn't catch, you can see why I use this one, if you didn't catch that flip of the symbol because I divided by a negative, you would definitely get this one wrong, and I don't want you to. I think that's it. Alrighty, have fun.